Hello, in this video we're going to be talking about circumference and arc length. And our question is, how can you find the length of a circular arc? So a circular arc, if you need a visual, is if we started with a circle, but we only wanted to know how long part of it is, right? That part would be called an arc. So when we talk about arc length, we're actually talking about part of the circumference. So since we're talking about part of the circumference, let's go and review circumference real quick. The circumference of a circle is basically the distance all the way around the circle, okay? So you have to go all the way around the circle, and that distance is the circumference. So you can either say that the circumference is pi times the diameter to find out how long it is around the circle, or you can say that the circumference is 2 times pi times the radius because the diameter is the same as 2 times the radius. Okay, so let's use these formulas in a couple of examples. We want to find the circumference of a circle with a radius of 9 centimeters, and then we want to find the radius of a circle with a circumference of 26 meters. Okay, so two different problems. So the first problem, we know that the radius is 9 centimeters, and we want to find the circumference. Okay, so I'm going to use this formula that has c equals 2 times pi times the radius. So 2c equals 2 times pi times the radius is 9 centimeters. Okay, and when I multiply all that out, I find out that is equal to 18 pi cm. I just multiplied 2 times 9 to get 18. And this is what I need if the problem demands an exact answer, right? I'm not going to multiply it by pi if I need an exact answer. However, if the problem says that we want an approximate answer, I can go ahead and put 18 times pi into the calculator and find out that this is approximately 56.5 centimeters. Okay, so you need to know the difference between the directions telling you approximately how long or exactly how long. All right, and then for the second one, we want to find the radius of a circle with a circumference of 26 meters. So since c is equal to 26 and we're trying to find the radius, again, I'm going to use this equation right here, c equals 2 pi r. The c is going to be replaced with 26 meters. So 26 equals 2 pi r. Okay, I'm going to go ahead and divide both sides by 2. And that tells me that 13 equals pi times the radius. And then I'm going to go ahead and divide both sides by pi. And this time I'm just going to go with an approximate answer. Okay, pi and pi cancel out. So this tells me that the radius is approximately 4.14 r, right? But when you input it, make sure that you're acknowledging your units, 4.14 meters. Okay. So now that we've reviewed circumference and either finding circumference or using the circumference to go back and find the radius, let's talk about arc length. Okay, so when we find the length of an arc, we're actually finding how long it is from one end to the other end. We're finding how long that portion of the circumference is. Okay, so you can build a ratio where you're finding the arc length of AB over 2 pi r, so the portion of the circumference over the whole circumference equals the measure of AB. Now this right here specifically, when you have an M in front, that means that they're talking about the size of the central angle. With the M means the size of the central angle, okay, over 360 degrees because that's all the way around the circle. Okay, I like to actually rewrite this. So I prefer this particular version of the formula where we've got the arc length of AB. Now, I don't need the words arc length of. I can just say arc AB. I know that since there is no M located in front, this is talking about length, not angle. Okay, so this is going to be the measure of the angle, the central angle, over 360 degrees times 2 pi r. Okay, so times the circumference, right? So I could also rewrite this and say that this is AB equals the angle over 360 degrees times the circumference. And if I just put a capital C there, now I can either use 2 pi r or I can use pi times the diameter d. So let's apply that to these problems right here. We have find each indicated measure. We want to find the arc length for this first problem. So we just need to find out how long this arc is. We want to find the circumference all the way around for this second problem, knowing that this arc is 4.19. And then for the last one, do you see this little M right here? That actually means that we're going to find the central angle. Right? So we're going to find the central angle knowing, again, how long this arc is. That's going to be 44 meters. Okay, so let's get started. To find the arc length of AB, I've got AB as an arc equals the angle, the central angle 360 degrees, or 60 degrees rather, so 60 over the full circle, 360, times the circumference, and the circumference is 2 pi r. So 2 times pi times 8 centimeters. Okay, so when I multiply this out, right, I could, if I need an exact answer, I could reduce the fractions and all that good stuff, and I could find that AB, the length of arc AB, is 8 pi over 3 centimeters, because I'm aware of my units. Or if I need an approximate answer, I could say that the length of arc AB is approximately 8.4 centimeters. Okay, so I used an equal sign to mean an exact answer and the squiggly equal to mean an approximate answer. Okay, so let's do this next problem. We need to find the circumference knowing the arc length. So I'm going to put this in place of arc xy, right? So this is going to be 4.19 equals my central angle, 40 over 360 times, I want to know the circumference. So just C, okay? If I reduce this fraction, it turns into 1 over 9. So 4.19 equals 1/9 times C, okay? And the way that I can get rid of this fraction is by multiplying by the reciprocal, which is just 9. So I'm going to multiply by 9 on each side to cancel out that fraction. And when we multiply 9 times 4.19, we find out that this circle all the way around has a full circumference of 37.71 inches. Okay, and I'm using a decimal given from my problem, so I'm going to keep my answer as a decimal, and I'm just going to call that good. All right, and then for the final one over here, we want to find the central angle, right? So I know the arc, right? That's the arc. I know the radius, so I can find the circumference, right? So let's plug things in where we can do them in our equation, right? The arc, RS, is going to be 44. The central angle is what I don't know, over 360. And then times the circumference, but I'm going to write the circumference based upon this radius right here. So 2 times pi times the radius, 15.28. Okay? Now, if you multiply 2 times pi times 15.8, okay, this part right here is going to turn into 99.27, right? So we've got 44 equals, I'm going to use A for angle over 360 times a full circumference of 99.27, right? And then in order to isolate the A, I'm going to go ahead and divide both sides by 99.27. So divide by 99.27. And then I'm also going to multiply both sides by this 360 divisor. So times 360 and times 360, right? So just as a reminder, the 99.27 got canceled out by dividing, and this 360 got canceled out by multiplying. Okay, and if we put this in our calculator, 360 times 44 divide by 99.27, we find out that the central angle, so the measure of RS, of arc RS, is 165, right? If I'm going to write that using the correct mathematical notation, based on what I was given up here in the problem, I would say that the measure of arc RS is 165 degrees. All right, so let's apply arcs to finding distances. In this problem, the curves at the end of the track shown are 180-degree arcs of circles. Well, that's cool because that means that from here to here, this is half of a circle, right? So that's half of a circle. And then if I take the other side from here to here, right, this is the other half of a circle, okay? Or if I was looking at the blue, I could say this is half of a circle, and the other side is half of a circle, okay? And then this length right here, 84.39 meters, is repeated up here, 84.39 meters, okay? The directions say the radius of the arc for a runner on the red path shown is 36.8 meters. About how far does this runner travel to go once around the track? So we don't even care about the blue, okay? So for the red path, we have a full complete circle. So that's going to be 2 pi times the radius, which is 36.8 meters, plus this length of 84.39, plus this other length of 84.39, and that will take this red runner all the way around the circle, okay? And when we put this into our calculator, we find out that the length of the red path is approximately 400.00, because, and that's the decimals that I got. So I'm just going to round that, and I'm going to say that the red path to the nearest tenth is 400 meters. Okay. Now, you notice that I have been putting degrees on things, right? Like in here, this problem right here has a degree symbol on it. It's because of this next part. Okay, so this next part, what is a radian? Well, if we take the length of a radius and rotate that around to the side of our circle, now bend it, that arc covers an angle measure of 1 radian. And if we count how many of those go around the circle, that's 2, that's 3, but we've got a little tiny bit left to get to the rest of that part, and that little tiny bit is the 0.14 part of pi, okay? So half of a circle is pi radians, all the way around the circle is 2 pi radians, okay? And that GIF will replay if we just let it replay. So to restate what this is saying is that let's just replay it for a second. Where this stops right here, right? This angle right here has a measure of 1 radian, and it is approximately 57 point something degrees. It's just shy of 60 degrees. Okay, if it was exactly 60 degrees, then we would need perfectly 6 radians all the way around our circle. But what we actually have going on is that it takes 6.28, so on and so forth, radians all the way around the circle. So that is 2 pi. Okay, so a radian is just another way to measure an angle instead of using degrees. Like you could measure the distance from your front door to your back door using feet. You could measure it using meters. It's just another way of measuring. All right, to convert between degrees and radians, we're going to use the fact that it takes 2 pi radians to get all the way around a circle, or it takes 360 degrees to get all the way around a circle, okay? Or you can also use the fact that it takes pi radians to get halfway around a circle, or 180 degrees to get halfway around a circle, okay? That's how you convert from degrees into radians. If you want to convert from radians into degrees, you just flip your fractions, okay? So in order to convert 45 degrees into radians, I'm going to take 45 degrees and multiply that by pi radians over 180 degrees. And you will notice the degree in the numerator cancels the degree in the numerator. Okay, when we convert this to radians, what we actually want to do is just reduce the fraction. Okay, and 45 goes into 180 4 times. So 45 degrees is the same as pi over 4 radians. And for radians, we actually don't even use a symbol. We just know that if it's pi over 4, radians is implied. Okay, so let's look at this problem. We have convert 3 pi over 2 radians to degrees. So in order to convert from radians into degrees, I'm going to take the radian measure, 3 pi over 2, and multiply that by this right here, 180 degrees over pi radians. So 180 degrees over pi. And again, we have pi in the numerator canceling pi in the denominator, so those will cancel out, right? I can reduce my fraction, and when I reduce my fraction, I don't cancel out this degree symbol, that's important. This is actually 3 pi over 2 is the same as 270 degrees, okay? So let's just think about that for a moment if we can. To go all the way around a circle, so from here all the way around the circle is 2 pi, okay? To go from here halfway around the circle is pi, okay? To cut that in half, right? To go from here only halfway to pi, that would be pi over 2. And you can kind of see already that this right here would be a 90-degree angle, okay? So now I'm going to count by 90 degrees. I've got 90 plus another 90 is 180, plus another 90 is going to be 270 degrees. If I count that in radians, I've got 1 pi over 2. Here I've got 2 pi over 2. And then down here, this would be 3 pi over 2 is the same as 270 degrees. Okay, so hopefully that helps you understand radians and degrees, how they both measure the same thing, just in a different way. And hopefully you've been able to glean something about the length of arcs. Thank you very much for watching. I'm going to let this thing play one more time just because I think it's fun.